that is semiconductor electronics. In your syllabus, it is the last chapter, that is semiconductor electronics. So in this chapter we are studying detail regarding the semiconductor. What do you mean by semiconductor, where these semiconductors are used, and what are the types of semiconductor and everything. So let us begin with semiconductors. Let's basic introduction regarding the semiconductor is semiconductors are electronics devices which are used everywhere where the electronic circuit is there. Electronic circuit ಎಲ್ಲೆಲ್ಲಿ ಇರ್ತೈತಲ್ಲ ಅಲ್ಲೆಲ್ಲಿ semiconductors ಯೂಸ್ ಮಾಡಿರ್ತಾರೆ. Earlier semiconductor was not there, the vacuum tubes were used. Vacuum tube with size bhal doddiದ್ದಕ್ಕೆ it was replaced by the semiconductor. So semiconductors are used in almost all electronics circuits, like your mobile phone, or you can take televisions or the computers. Everywhere the semiconductors are used. So semiconductors are also kind of solids. It is a kind of solid, and let us see the classification of solid. Classifications of solids. How we can classify the solids? Let us begin with the classification first. First topic or first bit is classification of solids. Solids can be classified as first one, conductors and insulators and semiconductors. So what are the conductors? You have already basic idea regarding the conductors which allows the current electricity to flow through it, or you can say conductors are the materials, are the solids which has very low resistivity or very high conductivity. Conductor ಒಳಗೆ ಹೆಂಗಿರುತ್ತೆ, conductivity ಬಹಳಷ್ಟು ಹೆಚ್ಚಿರುತ್ತೆ, resistivity ಬಹಳಷ್ಟು ಕಡಿಮೆ ಇರುತ್ತೆ. Like resistivity, like its conductivity lies between 10 raised to 2 Siemens per meter to 10 raised to 8 Siemens per meter, and its resistivity vary from 10 raised to minus 2 ohm per meter to 10 raised to minus 8 ohm per meter. 10 raised to minus 8 ohm per meter. So here I guess it is 10 raised to minus 2 to 10 raised to 8. So here conductivity and resistivity are inversely related to each other. Conductivity for the conductors is very high, like 10 raised to 2 to 10 raised to 8, 10 raised to 2 to 10 raised to 8 Siemens per meter, and resistivity varies from 10 raised to minus 2 ohm per meter to 10 raised to 8 ohm per meter. And similarly, insulators are the solids which do not allow current to flow through it, or you can say it has very high resistivity and low conductivity. Or you can say insulators are the materials those who have very high resistivity and low conductivity. ಇಲ್ಲಿ resistivity ಬಹಳಷ್ಟು ಇರುತ್ತೆ, conductivity ಬಹಳಷ್ಟು ಕಡಿಮೆ ಇರುತ್ತೆ. So conductivity is of order of 10 raised to minus 11 Siemens per meter to 10 raised to minus 90 Siemens per meter. And similarly, resistivity is vary from 10 raised to 11 Siemens per meter, ohm per meter to 10 raised to 90 ohm per meter. And now we have basic idea regarding conductors and insulators. Now what do you mean by semiconductors? See, conductor are the solids which have very high conductivity, and insulators are the solids those have very low conductivity. Then what do you mean by insulators? Insulators are the solids whose electronic property, or you can say electrical properties, lies in between conductors and insulators. Eternal property, eternal conduction property lies between insulators and conductors. Such materials or such solids are called as insulators. So semiconductors. Semiconductors are the solids whose conductivity lies between conductors and insulators. For example, its conduction or conductivity is 10 raised to minus 5 Siemens per meter to 10 raised to 6 Siemens per meter, and similarly its resistivity vary from 10 raised to 5 ohm per meter to 10 raised to minus 6 ohm per meter. So you can see here resistivity or conductivity lies between conductors and resistors. So these are the solids, these are the classification of solids. Let us recall it. Solids can be classified according to their conduction or resistivity property. We can classify into three groups. One is conductors, and one is insulators, and one is the semiconductor. So conductors are the solids whose electrical property, like conductivity is very high, and insulators are the solids whose conductivity is very less, and you can say the semiconductors are the solids whose conductivity lies between insulators and the conductors. So example for conductors are, if you state the examples like copper, silver and gold, etc. You can state some examples. And insulators, if you state the examples for insulators like wood, rubber, and you can say plastic materials. And also for the semiconductors, examples are germanium and silicon are best example for the semiconductor. So these are the classification of solids, depends upon their electrical properties. So next concept is, we have seen that solids are classified according to their conduction property as conductors, insulators and semiconductors. Why it is happening so? Why some materials falls under the property under the classification of solids, and some materials or some solids fall under the insulators, and why some solids fall in the category of, you can say, semiconductors. We will see why it is so. See, listen to it very carefully. That concept is called band theory. What do you mean by band? Energy band. What do you mean by energy band, and how it come and all? We will see here. If you take an isolated atom, if we consider this as an atom and it has several electrons revolving around it. It is what the nucleus is, and it is the first orbit of the electron, second orbit and third orbit, we can say. And orbits according to their energy level of electrons revolving around the nucleus. If you take electron in the outermost orbit, I can say that energy of this electron is very high compared to first orbit, right? So here you can say electron in this orbit has very high energy compared to this and this electron. So if we take an isolated atom and if we consider the electrons, I can say that this electron has the maximum energy level, and this electron has bit lower energy level, and this electron has bit lower energy level. What I want to tell here is, if you take an atom, isolated atom, we have separated atom from the material. Yavado the material indra atom anna separate mari. If we see that atom, that is called isolated atom. We are separated that atom from the material. So this atom, if we consider, and electrons if we take, all the electrons have their own energy levels. If we consider single electron, we can say that all electrons have their energy levels. Is it clear? Then, so these are what the energy level, sharp energy level we can say. If you take a solid, ಯಾವುದೋ ಒಂದು ನಾವು solid piece ತಗೊಂಡಿರಪ್ಪ ಅಂದ್ರೆ, they have a number of atoms. In this, the number of atoms are present. Several atoms are present. These are all atoms I can say. So the material is same, and atoms in that material all are same. And if you take the valence electron means what? Electron which is present in the outermost orbit. The energy of that outermost orbit's electron is same. In almost all the atoms, energy is same. If we draw the energy, or you can say energy level of all the electrons, I'll get one electron has this much energy. If I take energy, one electron has this much energy. If this atom's electron has this much energy, and second atom's electron has this much energy, and another atom's electron has this much energy, and these all energies, if we consider all the energy of single atom, then we get the band of the energy. This band of the energy is because of valence electron. All valence electron energy level we have considered. We have considered the energy of all the valence electron. But if we see here, only one energy level is not there. But several energy levels are there. Considering all the electrons, all the outermost electrons present in the material, hence band is formed. This band is called valence band. This band is called as valence band because of valence electron, you can see. Is it clear? So valence band is because of all the valence electrons present in the material. Those electrons have different energy levels. Why it is so? Why it has different energy levels? If you ask this question, you have answer right. If you consider this atom, electron revolving in this atom is attracted by its molecule, its nucleus. You can say this electron is attracted by its nucleus, and also the same electron is attracted by the neighboring nuclei. Hence, its energy level is different from other nucleus. Hence, instead of forming an energy level, here energy band is formed. If formed energy band is because of valence electron, then that is called as valence band. And this is what the valence band is. Further, and this is at 0 Kelvin. If you take same example, same material in the room temperature, the valence electron, because of presence of heat in the room temperature, heat is get absorbed by the valence electron, and that energy is sufficiently enough to get removed from the valence band. ಏನಾಗ್ತವ್ರಿ, ಅವು ಎಲೆಕ್ಟ್ರಾನ್ ರೂಮ್ ಟೆಂಪರೇಚರ್ ಒಳಗಿಂದ ಎನರ್ಜಿ ಇದ್ದಿದ್ದು ಅಬ್ಸಾರ್ಬ್ ಮಾಡ್ಕೊಂಡು ಎಲೆಕ್ಟ್ರಾನ್ ಗೆಟ್ ಫ್ರೀ ಫ್ರಮ್ ದ ವ್ಯಾಲೆನ್ಸ್ ಬ್ಯಾಂಡ್. If electron get free from the valence band means their vacancy is created. If you consider a valence band and valence band get removed from that valence band, ಒಂದು ಎಲೆಕ್ಟ್ರಾನ್ ಹೊರಗೆ ಹೋಗ್ತೈತಿ ಅಂತಂದ್ರೆ ಆ ವ್ಯಾಲೆನ್ಸ್ ಬಾಂಡ್ ಒಳಗೆ ಒಂದು ವೇಕೆನ್ಸಿ ಕ್ರಿಯೇಟ್ ಆಗ್ತದೆ. That vacancy is nothing but the hole. Holes are absence of electron. You can say holes are absence of electron. Now, suppose at the room temperature, if you take the solid at room temperature, at room temperature. Here the atoms are there. Same number of atoms are there. Due to exposure of the room temperature, the valence electron absorbs the thermal energy and they get removed from or they escape from the valence band. Valence bond intra ಹೊರಗೆ ಬರ್ತಾವೆ. Valence bond intra ಹೊರಗೆ ಬರ್ತಾವಪ್ಪ ಅಂತಂದ್ರೆ they are free from the nucleus. They are free from the nucleus force of attraction. Those all electrons are responsible for carrying current. These electrons have the energy level. Once again, these electrons, escape electron, have the energy level, but these energy level bit higher than the valence electrons energy because they already absorb the thermal energy and valence energy through hange irtati. Once they absorb the thermal energy, the electrons energy more than the valence energy, and we can mark somewhere here. It is only energy level of only one electron. There are so many electrons are there, so we can mark the energy levels like this. Several energy levels I can mark like this. So these all are constitute a band. These all electron energy levels constitute a band that is called as conduction band. So we have got valence band and conduction band, and difference between or the gap between these two is called as energy gap. It is noted by EG, energy gap. So depends upon this gap, energy gap, we are classifying solids into once again into conductors, insulators and semiconductor. So before going to that classification, let us define conduction band and valence band. As we know so far, valence band is completely filled with valence electron. Valence band is completely filled with the valence electron yavagri when the temperature is in 0 Kelvin. So energy band which is completely or partially filled with valence electron at 0 Kelvin. Such energy band is called as valence band. And the next is conduction band. Conduction band, here at 0 Kelvin it was not there. At 0 Kelvin 3 it was not there. But above the 0 Kelvin means at room temperature this band is present. So conduction band can be defined as it is an energy band which is completely or partially filled with conduction electron. Yav electron re conduction electrons at room temperature, but this conduction band is completely empty at 0 Kelvin. So these are the definitions regarding conduction band and valence band. So we will see the classification depends upon this. So now we have clear picture about the valence band and the conduction band. Depends upon the distance between the valence band and conduction band, we are classifying as solids as conductors, insulators and semiconductors. Let us see first one, the conductors. How can we classify conductor? Depends upon the band theory, conductors. So this is regarding the classification of solids depends upon the band theory. How can we classify the solids? It depends upon the energy bands, gap between the energy bands. If I take this is the conduction band, this is the conduction band, and another one is this is the valence band. So if the situation is like this, how it is, the conduction band is overlapping the valence band. If the situation is like this, then those materials or those solids are called as the conductors. Here conduction band, conduction and valence band overlap each other. So such situation, such solids are called as the conductors. So here there is no gap between the conductors and the conduction band and valence band. These kind of materials behaves like the conductors in almost all the temperatures. So next one is insulators. 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 If you take the conduction band, this is what the conduction band is, and this is what the valence band is. So valence band and the conduction band. Conduction band. Now if and this gap is energy gap. We already know this. Energy gap, if it is more than 3 electron volt. This is what the basic picture regarding the insulators. Now you can say, if the energy gap between conduction band, if the energy gap between the conduction band and insulation band, valence band, conduction band and valence band is more than 3 electron volt, such kind of solids is called the insulators. Energy gap must be more than 3 electron volt. What it means is, if you supply the energy more than 3 electron volt, then the electrons start jumping from valence band to the conduction band. If the energy is less, it remains as the insulator. Then third one is semiconductors. Semiconductors. And here, if this is the conduction band, it is a semiconductor, and this is the valence band. Valence band, and this is the conduction band, and this is the energy gap. If the energy gap is less than 3 electron volt, between what and what? Between the conduction band and the valence band. If the energy gap between conduction band and the valence band is less than 3 electron volt, such solids are called as the semiconductors. So semiconductors are the materials or solids where the gap between energy gap between conductors. Then semiconductors are the solids where the energy gap between conduction band and valence band is less than the 3 electron volt. Means what do you mean by this is, when you supply the energy which is less than 3 electron volt, the electrons in the valence band start jumping from valence band to the conduction band. It is easily becomes conductor. Semiconductor easily it can be converted into conductor when energy is given. Means when the semiconductor kept at room temperature, the electrons start absorbing the heat energy, thermal energy, and those electrons start jumping from valence band to the conduction band. Hence the semiconductor becomes conductor there. So these are the classification depends upon the energy band theory. First one, conductors, where we can say the conduction band and valence band overlap each other. Insulators, where the conduction band and valence band is separated by the energy level more than 3 electron volt, and the semiconductors are the solids where the energy gap between conduction band and valence band is less than 3 electron volt. So these are the classifications of the solids. So this is regarding the classification of the solids. We have classified solids into conductors, semiconductors and insulators. Depends upon the conductivity as well as the energy band theory. So far we have studied this much, and in the next class we shall study the classification of semiconductor. What are the types of semiconductors and all, we will in the next class. I'll stop here and